of of the remaining parts. For example, if I have to find out minor of 2, minor of 3 of each element, value determinant obtained by finding the determinant value of the remaining matrix of a particular element leaving the rows and columns in which that element lies. What does it mean? Minors of the matrix A. The minors of the matrix A are obtained by finding the determinant value of the remaining matrix of a particular element, leaving the rows and columns in which that element lies. So remaining of every element, for example, 2, what is the minor of 2, minor of 3, minor of 4, minor of 5, minor of 6, minor of 7, minor of 1, minor of 3, minor of 4, minor of every element's minors we have to find. What is that process? For example, if I have to find out minor of 2, then leaving this and this row in which this element 2 is lying, so that row is to be removed and that column is to be removed in which that element is lying. So remaining matrix is this 6, 7, 2, 3. We have to find the determinant value of this. 6 into 3, 18. 18 minus 7 is 14. 14. It is 4 difference. The difference 4 is the value minor of 2. So minor value is the determinant value of the remaining matrix of any element, particular element, removing or leaving that row and column in which that element is lying. Okay. In this way, we have to find out minors of each element. Every element minors we have to find out. So minor is this smaller matrix, or the value of the matrix which is smaller one than the original matrix is bigger one, and then we have to find out minors of every element. In that situation, to obtain the minors of any element, what we have to do, we have to remove that row and column in which that element is lying. For example, if I have to find out the minor of 3, minor of 4, okay, etc. Let me take minor of 3 here. Minor of 3. Now this column will be removed, this row will be removed. First row removing, second column removing. Remaining value is 5, 7, 1, 3. Now determinant value of this is 5, 3, 15 minus 7, 1 into 7 minus 7 is 8. 8 is the value of 3. Minor of 3 is 8. This is how minors are calculated. Okay. Minors of every element I have to find out in this situation. Then what is the difference between minors and cofactors? I have to just talk about. Now let me talk about cofactors simultaneously so that the point is clear. Okay, so this is the minus here without considering the sign. In case of cofactors, a cofactor of any element is equal to minus 1 raised to power I plus j, where I is the number of row, j is number of column. So the element in which that element is lying, the row and column in which that element is lying, that number of that row and that number of column in which that element is lying, that is added up, and minus 1 power that will give us a sign. It is negative or positive. If it is odd number I plus j, then minus 1 whole power odd is negative. If it is even number I plus j, even number, for example it is 2 plus 2, it may be 2 plus 4, then it is even number. So then minus 1 is or even number is positive. That value will be positive. So this is minus 1 raised power I plus j into minor. Okay, so in case of cofactors, a cofactor of any element is equal to minus 1 whole power I plus j into minor of that element. Into minor of that element. What does it mean? In this case, suppose I have to find out minor of 2. Therefore, cofactor of 2. Let me find out cofactor of 2. Therefore, cofactor of 2, which is the first element in first row, will be given as minus 1 raised power. This is first row, first column. First row, first column. It is 1 plus 1. Okay, into minor. Into its minor. Minor be calculated 6 3 are 18 minus 17. 14. So 18 minus 14 is 4. That means positive 4. This is plus 4. So here, cofactor of 2 is positive 4. First, let me take equation number. And cofactor of 3, second element of the first row, or the first element of the second column, is equal to minus 1 raised power I plus j. I is first row, second column. This is 1 plus 2 into minor. Minor is this 5 7 1 3. Let me write it as 5 7 1 3. We have to solve it. 5 3 15 minus 7 is 8. It is negative 8. So minus 1 is for 3 is negative sign. Minus 1, it is minus 1 into the value. Determinant is calculated by multiplying, cross multiplication and subtracting. 5 into 3 is 15. 15 minus 7 into 1 is 7. Okay, so that is, or we could write it as 15 minus 7. It is 15 minus 7 equal to, but big minus sign here, it is minus 8. 15 minus 7 is 8. It is minus 8 here. Alright, this is how we find out the cofactors of any element. Cofactor of any element can be calculated. Suppose we have to find out cofactor of 6. This is 6 here. Let me remove these lines. This is a cofactor here. Now, cofactor of 6, if I have to find out, now I'll define with the help of taking some algebraic example. Okay, so here it is. Okay, 6. We have to find out what is cofactor of 6. Now, cofactor of 6. That is second, this row and second column. So second row, second column. This is second column here, in which 6 is lying, and this is second row also. So it means this will be minus 1 is for 2 plus 2. Second row, second column. This is second column, second row, first row, second row, third row. So the 6 is lying in second row and second column. 2 plus 2 into what is determinant value, remaining minor, but is minor than of 6. So removing this row in which this 6 is lying and column, the remaining value is 2 4 1 3. It will be 3 1 3 to the 6 minus 4. Minus 1 is for 4. Let Let me write completely. Now this is 6 minus 4. This is positive value because 4 into 1 is 4 and 3 to the 6. 6 minus 4. So first this minus this. This is determinant value we have to find out. Now minus 1 is power 4 is positive. It is true only. Cofactor of 6 is 2. In this way, we can calculate cofactors of every element. 3, for example, cofactor of 3 will be. Now, in this situation, we have to remove this row in which this 3 is lying and this column. Then the remaining value will be these 4. 6 to the 12 minus 15. So minus 3 it will be minus 15 plus 12 is minus 3. And then minus 3 and 3 is lying in the third row, third column. So 3 plus 3 positive will be positive value. It will be plus sign multiplied negative value. 6, 12 minus 15, 12 minus 15 minus 3, which is minus 3 only. So cofactor of 3 is minus 3 only, because minus sign remains, because plus minus 1 is power 6 is 3 plus 3 6, that is even number. So minus 1 is power 6 is even positive number, positive value, plus this, so it was minus 3. Okay, so negative sign will remain. If it is negative into negative, then it will be positive. In this way we calculate cofactors of. Difference between minor and cofactor is that minor is having no sign of I plus j. Okay, this is help determinant value only. Determinant value. So difference between this is that minor has only the determinant value. Only the determinant value of the remaining matrix, which is obtained after removing or removing row and column, in which that element is a line. So that is the minor value only. Determinant value we have to calculate. In case of cofactors, cofactor is negative or positive value is the minor value multiplied by the minor value multiplied by minus 1 raised power I plus j, where I is number of row and j is number of column. Is number of column in which that element is lying, in which the element is lying, in which that element lies. Cofactor is a minor value multiplied by minus 1 is for I plus j, where I and j, I is number of row and j is number of column in which that element lies. This is how minors have no any positive negative sign of its own. Whatever the result comes out to be, suppose minor value comes out to be negative, and it is negative because of multiplication, okay, or subtracting the value, the second value of obtain this 6 into 3 18 minus this. If this value comes out to be negative of its own, then it is negative. So it is not multiplied by negative positive sign. It is determined by minus 1 is for I plus j. Difference is that minor value into positive or negative sign will give us cofactor. But while cofactor, minus is only the determinant value, which is obtained of the matrix, which is obtained by removing the row and column in which that element is lying. This is how the difference of cofactor and minor is. Question number 3 we have done. Now let me talk about question number 4. Now question number 4, what does it say? Question number 4 is, if A is, now what is the adjoint of a matrix? First let me, what is the adjoint of a matrix? First I have to define. If A is this, verify the theorem adjoint of A. What is the adjoint of a matrix? First let me define. Adjoint of a matrix now. Because adjoint, ADJOINT, adjoint of A, because we have to find out now adjoint. So adjoint of a matrix A, let me take, is what? Now I have to define what is adjoint of a matrix, is what? That is how adjoint, let me define. Adjoint of a matrix is what? Okay. A matrix of, or matrix obtained by transpose of the matrix of cofactors. Matrix of the cofactors. So a matrix obtained by transpose of the transpose of the matrix of cofactors is known as an adjoint of a matrix. An adjoint. So let me define it. Adjoint of a given matrix. Adjoint of a given matrix. Okay, so let me take what's adjoint. If A is a matrix, let us consider a matrix A as A is 20. Let me take A11, A1. These are the elements here. A13. Okay, these are the elements are taken. This is A21, A22, A23. Second row, third column. A23 means second row, third column. Now, next element, let me take A31, A32, A33. Okay, so this is a given matrix A. Now, what is the cofactors? Now, A11, if I have to find out. Now, let us take cofactor of A11. Now, cofactors of every element of matrix A is, now cofactors of every element of matrix A is written as, or let me, is defined as, let me find out. So cofactors matrix. So a matrix of cofactors of A to a matrix of cofactors of A, of matrix A is given by, let me write it here. If I write the matrix of cofactors, okay, as, now here it is, matrix of cofactors of A. So matrix of cofactors of A, let me denote it as capital A11, A12, A13, and this is A21, A22, A23, A31, A32, and A33. This is the matrix of cofactors. Okay, so this is a matrix of cofactors of A. Now, if I transpose this, therefore adjoint is equal to where A1, A2, A1, A11, A12, A13 are defined. Here A1, let me define them. Where A11, comma A12, etc. A33 up to A33 are the cofactors of elements A11, comma A12 up to A33. All these elements of this matrix A11, what is the cofactor of A11, what is cofactor of A12, which are represented as A11. They are the cofactors here. First we have to find out cofactors. After this we will transpose it. Therefore matrix of cofactors is transposed. Therefore adjoint of A, adjoint of A is transpose of A is transpose of this matrix, of the matrix of cofactors of A. Of a given matrix A is transpose, cofactors matrix is obtained. After that it is transposed. So that will be equal to, therefore adjoint will be A11, A12 will come here, A13 will come here. We have transposed or interchanged rows into columns. This is after interchanging rows into columns. This is A21, A22, and A23, and this is A31, A32, A33. So this is the matrix, adjoint of a matrix given. Now what are the A11, A21, A31? Let me define them cofactors. These cofactors are what? Okay, so we have A11, and here we A, the basic matrix as A11, A12, A13. This was our basic matrix. A1, A21, A22, A23, A31, A32, and A33. This is the basic matrix. Therefore, A11, if I have to find out, it's nothing but minus 1 raised over 1 plus 1. This is 1 plus 1 here. This is minus 1 raised power 1 plus 1 into determinant of the remaining matrix. That means this A22, A23, A32, and A33. This value will give us A11, the basic value. Similarly, A12 equal to minus 1 raised power 1 plus 2, negative value. And the remaining value, this A12 is, we will leave this row, for this column and this row. This is A21, this is A21, A23, A21, A23, because this is A12 lying in this column and this row, they are left over. So A1, A21, A23, and A31, A33. This is A12. Similarly, A13, That means minus 1 is for 1 plus 3. This is determinant value of A13. Is this column left, this row left, sorry, this one, A13. So A13, what is the cofactor of A13? That means these two values, A21, A22. Determinant of this value, A31, A32. Okay, with negative sign because this is minus 1 raised power 1 plus 3. Sorry, this is positive value. It will be positive, but second element is negative. This A1 will be negative. A13 is positive. Okay. In this way, we will calculate these cofactors. Now let me take one numerical question that will give us the clear illustration. Now question number 4, which is based on adjoint of the matrix. This adjoint, what is the adjoint of the matrix that I have defined? Now questions based on this adjoint of matrices. Then now questions. My questions. I have to take the questions now. First, let me clear this. Clean. It must. Okay. So question number now 4. We have to find out the adjoint of the given matrix. So let me find out adjoint. This is 7th question. This is 8th question. Okay, so now question number 4. It says if A is this, find the adjoint of A. Adjoint matrix of A. We have to find out adjoint of A. So here question number 4. It will clarify everything. If A is given as a matrix 1, 2, 0, this is minus 1, 3, 4. This is minus 2, 5 and 6. Okay. Alright, so find the adjoint of matrix A. So here again 3 by 3 order is missing. So we have to find out what is matrix of cofactors. Cofactors matrix. So matrix cofactors, matrix of cofactors of A. Matrix of cofactors of A is given by, as I just defined here, A11, A12, A13. Okay, A21, A22, A23, A31, A32, A33. We just write like this. This is suppose cofactors matrix. Now A11 we have to calculate. A11 is 1 here. A12 is 2. A13 is 0. In this way, each element's cofactor we have to find out. What is A11 here? A11. Let me find all these 9 elements. Right. First is A11. I have to just write here A11 equal to how much? A12 equal to how much? I'll just calculate. A13 is what? A21 is what? A3, A22 is what? A23 is what? A31 is what? A32, sorry. A32 is equal to what? And A33 is what? All these values we have to calculate 9 values. 3, 3 and 3. Total 9 values. All these cofactors we have to find out of every element of this. Okay, so A11, let me take. This is positive value because 1 plus 1 minus 1 is 4. 1 plus 1. And this is 1 here. So this remaining matrix 3, 6 or 3, 4, 5, 6. Let me write here. This is 3, 4, 5, 6. Let's calculate this. Minus 1 is power 2 is positive. This value 6, 3 are 18. Determinant, how will you calculate? First multiply this. 3 into 6, 18. And 5 into 4, 20. 5 into 4 is 20. 5 into 4. Then minus sign. In between we always keep 5 into 4. this is 20. So this is negative minus 2. So this value is minus 2. A11 is minus 2. Okay, so this we have calculated. Now let us take A12. This is A12. A12 is equal to, now this is minus 1 raised power 1 plus 2. That means negative value. And determinant value is 2 of 2. A12 is 2 here. So determinant of 2, this row left over, and this column left over, this is minus 1, 4, minus 2 and 6. Okay, so 2 is lying in the second column and the first row. First row and second column left over. Whatever value comes out, the left over is minus 1, 4, minus 2 and 6. We have taken. We have to determine this value. Determination of this value is simply this. This minus 1 raised power 1 plus 2 means 3 is negative value. This is minus 1 into 6 into minus 1 is minus 6. Minus in between we keep, but this is minus 2 into 4, negative value. So that will be minus 8, but minus 8 is plus 8 now. Minus become plus. This is minus sign multiplied, but 8 minus 6 is 2 in positive in bracket, but when multiplied by minus sign, it is also minus 2. So it will be minus 2 here. Why? Because inside the bracket it is positive value 2. 8 minus 6 is 2, but minus 1 is multiplied, it is minus 2 here. This is also minus 2. Now A13, let me calculate. In this way, the cofactors of every element we have to calculate. Therefore, A13, this is 0 here. What is cofactor of 0? So this row and this column left over. So this is nothing but minus 1 raised power 1 plus 3 is positive. Then determinant value is minus 1, 3, minus 2 and 5. Because this 0 is lying in the third column and first row and third column left over, removed. Whatever left over value is the determinant value. This we have to calculate. Now this is positive value. So minus 1 is positive, 4 is positive, with plus sign. And multiply to 5 into minus 1 is minus 5. Minus sign we keep in between. This is minus 2 into 3 is minus 6, minus 1 plus 6. It is only plus 1 value. It is 1. 6 minus 5 is plus 1. Okay, so this